Okay, so our project was, I think, a fairly ambitious project to try to do in 2 days, kind of 3. But it was kind of a web-based runtime debugger to help teach low-level programming concepts. And basically, we got most of the back-end stuff done. We have a JavaScript API that simulates assembly language instructions and builds memory, and can take a executable, convert that into assembly language, and run through several of the instructions. We haven't added every assembly instruction imaginable, but we have most of the common ones that are used for C and C++ programs. So that's about as far as we got. We got a JavaScript API mostly put together. Anything else?
We have a super badass hook system for JavaScript now. So if you want to have if you ever have the need for some sort of JavaScript hook system, I'll give it to you. But basically, if you need the ability to call an arbitrary name that is connected to a series of functions that call themselves, let me know.
Yeah, and it was I think it was an ambitious project to start with for the time frame. We expected to have 5 people here to work on it, and 3 of them couldn't make it, so that was convenient. But yeah, it was fun to work on. We got to dig into a lot of low-level stuff, and it's a learning experience.
You guys going to keep trucking on it?
Yeah.
Right on. It's a very interesting tool, especially for educational use.
Yeah.
So.
We have buffer overflow detection in it too now.
Yeah, I think it's probably the first time anybody's ever done buffer overflow detection with JavaScript.
That's pretty cool.
A little ridiculous.
Yeah.
And then, are you guys going to hook into like real-time execution profiles as well?
Yeah, there'll be the ability. Hopefully, eventually, we could figure out some way to securely do dynamic memory allocation, things like that, heap operations. Right now, stack stuff's easy to do because you can do it offline. The heap stuff's a little bit more complicated. I don't know if that means we'd have to run it in some sort of virtual environment or completely simulate DLmalloc with JavaScript, which doesn't sound fun.
Okay, with ASM did.
Yeah.
Well, that's sweet. It's super ambitious, so yeah.
So, from a programmer's perspective, I write my program and then I send you the assembly, or I send you the
You would be able to submit C code, basically, and you just put that into a field, and you would get 2 planes that would allow you to see your C code, and then at the same time see where it is, where that line of C code is represented inside of assembly. And then also with that set of assembly, you get to see the stack and where it currently is in the state. And we're also going to have the ability to have a scrubber so you can go back and forth between lines and actually see how the stack was affected over time. And that actually is implemented. So every time the stack updates or a new function is called, I guess actually instruction is called, we take a snapshot of what the stack is and like all the global variables, and you do have the ability to go back and forth between them.
So that's kind of what separates it from a normal debugger. Is a normal debugger, you have to start, set a breakpoint, run, stop, examine what you're doing, and then if you want to do the same thing over again, you have to do that over again. So one of the benefits of this is you could go forwards and backwards because it saves your state for each instruction.
Yeah, going backwards thing, so that's kind of the most novel aspect.
Yeah.
And so you're using a compiler to get the assembly?
Yeah, so you take the C code, it gets compiled by GCC with debug symbols.
Yeah.
And then we're just using objdump to grab the debug symbols.
But by the way, if you ever have to compile using GCC and PHP, we learned, put, invent, EMV. Basically, GCC will completely crash and just fail if you don't have your path set correctly because it's
you have to reset your environment.
That was like an hour of work.
So you save the state each time an instruction executes?
So every time an instruction executes, we have this big variable called global globals, which contains all your flags, the stack, all your registers at that point in time, and then other bits of arbitrary data. And it gets saved along with the actual address of the instruction that was called.
Okay.
And that gets put into a massive array.
It's all just saving the changes that are made to it.
Yeah. And basically you just, when you go back to that state, you just initialize everything from whatever is inside of the globals variable.
Yeah, so you wouldn't use this with like a large application because you quickly run out of memory with JavaScript. But it's good for, testing small code segments, looking at, you might use it to look at data structures on a low level, or any security things like stack-based buffer overflows or anything
Did you
like that.
save the segments, like, so that if you have, like, if you were building something larger and you wanted to break it down into segments first, would that be possible with the
If you can separate any code that would compile into C, then yeah.
Yeah.
Or I guess,
So it's like a microscopic, like, not microscopic, micros, like, of what like, the programming is.
Yeah, and Jeff back there showed us a little bit ago, somebody has a project where they actually completely emulate a computer with JavaScript. So I haven't got a chance to look through the code of that yet, but it seems like
Ambitious.
something
It's a
that
good
I
start.
probably want to check out. Yeah.
That's awesome.
That's slow sounding,
Yeah.
but
Yeah,
awesome.
Apparently it's very slow.
Well, thank you guys very much.
Thank you.